Now we're going to look at triangles and different centers of triangles. We have several different ones we're going to look at, and then we're going to do a couple of examples like what you can expect to see in class. The first one we're going to look at isn't really a center, but it's an important part. This is a midsegment, which a midsegment connects midpoint to midpoint. Okay, so you need to know that it connects midpoint to midpoint. So because we have three sides in our triangle, we have three midpoints. And if we connect all of those midpoints, we end up with three midsegments. All right, so our midsegment theorem tells us that the midsegment is parallel to the third side that it doesn't touch. Obviously, they're parallel. And it's half the length. So, for example, if I look at this side, EF, okay, that one connects the midpoint for BC and AC, so E and F, and it's going to be parallel to the side AB because that's the side it doesn't connect a midpoint to, and it's also half as long. All right, and that relationship holds true for all of the midsegments and their opposite sides. So the types of problems we'll see with midsegments is it'll say if AB is 36, so if this whole side here is 36, I want to know how long EF is. Well, EF is a midsegment, so it's parallel to that AB and half as long, so that means that EF is 18. Or if DE, so if this midsegment here is 3/2 x plus 5, and then BC, this whole side here, is 4x minus 1, I want to know how long or what x is. So the relationship is that this is a midsegment, so it's half as long as the BC side, so it takes two of the midsegments. So I would say 2 times 3/2 x plus 5 has to equal, so two of these has to make up one of the sides of the triangle, 4x minus 1. 2 times 3/2 is just 3. 2 times 5 is 10. I'm going to get 4x minus 1. So if I subtract the 3x over, I get x. And if I add the 1, I get 11. So then x equals 11. And then for the third one, the perimeter of the triangle ABC, so the big triangle is 64. Well, remember that AB is twice as long as EF, and then AC is twice as long as DF, and BC is twice as long as DE. So all the sides of the triangle are double the length of the sides of the triangle the midsegment makes. So that means that the perimeter is going to be half. So half of 64 is 32. Okay, so you just have to remember that midsegments connect midpoint to midpoint, and then they are parallel to the opposite side and half as long. Okay, the types of centers that we're going to look at, and I don't know what happened to all of the writing here. Okay, we'll just leave that. So the centers that we'll look at are the perpendicular bisector, okay, which is perpendicular to a side and passes through the side's midpoint, because remember a bisector cuts it in half. So a perpendicular bisector cuts each side in half at a right angle, and they're all going to intersect at one point, and that point we call the circumcenter. And a property of the circumcenter is that it's equidistant from the vertices, which means it's the same distance from all three vertices. Okay, so if I draw a triangle here, okay, and I'll change colors and say that this is a midpoint, and these are my three midpoints, okay, then I'm going to have to draw a line that's perpendicular. So if it goes up here, it's a rough looking perpendicular there, and then you'd have one right about there. Okay, all of these are right angles, and they're always going to intersect at one point, because you can only have one point for three lines that intersect at the same time. That point is my circumcenter. Okay, and then that point in comparison to all of the vertices, which are the corners of my triangle, is the same distance. So all of these distances are the same. Okay, so perpendicular bisectors intersect at the circumcenter. Medians go from vertex to midpoint. Okay, so if I draw my triangle over here, all right, and I'll label my midpoints. I have three medians in a triangle, so it's going to connect corner to midpoint. And again, they're all going to intersect at one point, and that point we call the centroid. All right, the centroid has two things. One is the center of gravity, so if you imagine taking your triangle, all right, and balancing it on that point, that is the centroid. All right, so if I put it on like a triangular piece here, this would bounce because it's the center of gravity. So it all evens out to the centroid. And then it's also 2/3 along the median. So from vertex to midpoint, it's 2/3. The easiest way to think about that is that from vertex to midpoint, you have 2x. Then from centroid to midpoint, you have x. So the whole thing together makes up 3x. And we'll do an example of that in a few minutes. We also have an angle bisector that divides the angle into two. Again, bisect means to cut in half. So we have 3 angles to bisect. So whenever you draw your triangle and you cut your angles, it was rough. You cut your angles in half. If I can draw it correctly, they're all going to intersect at one point, and that point is the end center. All right, so again, I'm cutting the angles in half, so that means that all of these are the same. All right, they intersect at your end center. Then your altitude, remember we always say that the altitude means the same as height. And we talked about how your height has to make that right angle with the base in order to be the height, because you don't measure something slanted, right? You go see how tall it is from the ground going straight up and down. All right, so the altitude goes through a vertex, and instead of going to the midpoint like a median, it's going to go straight down to the other side and make that right angle. And again, because we have 3 vertices in a triangle, we have 3 altitudes, and they're all going to intersect at the orthocenter. All right, so if I were to take this vertice and go 90 degrees, there's 1 altitude. All right, then this one looks like it would come this way some. There's my other altitude, and then this one would make a right angle there. And where they intersect is the orthocenter. So we have all these centers we're looking at: the circumcenter, the end center, the centroid, and the orthocenter. All right, you've got to know those 4. And so one example of what you'll see is with the centroid. Okay, so remember the centroid is from vertex to midpoint, and the distance is 2/3 of the way. Right, so that means with that triangle that we drew, all right, we said that we had 2x, x, and then the whole thing was 3x. All right, because it's 2 of the 3 x's on the vertex to centroid. All right, so the types of questions. We say if VT is 7, so if this section here is 7, QU is 36, so this whole part QU is 36. I want to find PV and QV. So PV is this part here, and then QV is this part here. We'll call that one Y. So to start with, if I look at the X, this section here that I'm looking PV, that's the 2x part, and X is 7. So if I know X is 7, 2 times 7 is 14. For the QV, that again, that's a 2x part, but I know that the 3x equals 36. So if 3x is 36, that means 1x has to be 12. So then the Y is a 2x part, so it's 24. All right, break it into thirds. 2 of the thirds goes in the long side from the vertex. 1 of the thirds goes in the short side going to the midpoint.